learn about determinant. You have already learned about matrix in earlier classes. Now we will see what is determinant. Though we have learned matrix earlier, it is quite astonishing that the idea of determinant came earlier, around 100 BC in China. While the idea of matrix was established around 1850s, and then the idea of determinant transformed and was developed through years. Then A.L. Cauchy in 19th century established the current form of determinant. Now let us see a square matrix of order 2 which looks like this, and this is a matrix of order 2. We remember that a square matrix is a matrix which has equal number of rows and equal number of columns. Here the number of rows and the number of columns are both 2 because this is a square matrix. Now we take a similar table of numbers in 2 rows and 2 columns. If it is a matrix, it looks like this. Now if we omit the brackets and introduce 2 new lines like this, then this is called a determinant. Now so this is a determinant. So what we have learned, that determinant always have same number of rows and columns, always have same number of rows and columns. Here 2 rows and 2 columns. Now we will see what is order of determinant. What is order of determinant? Now we take a determinant of 2 rows and 2 columns. Then it will be called a determinant of second order because 2 number of rows and 2 number of columns. Now I take another determinant with 3 rows and 3 columns. It will be called a third order determinant. So we may conclude that number of rows or columns is the order of the determinant. Because in rows or columns, why? Because rows and columns are equal in numbers in determinant, so the number of rows or the number of columns is the order of the determinant. Now we will see expansion of a determinant. What is expansion? Actually there was no such term while we learned matrix, but there is a value associated with each determinant, so we have to determine that value. So we take first determinant of second order, that is 2 rows and 2 columns. So how could we find the value of this determinant? So what would be the value? So first we will multiply A with D, so AD, then we will give a minus sign, then we will multiply B with C, so it's BC. So AD minus BC is the value of this determinant. Now we will see what is minor of a determinant. First take this determinant of third order, that is 3 rows and 3 columns, and we will find out the minor of the element A. So to find the minor of the element A, what will we do? We will highlight the row containing A and the column containing A. Now see the not highlighted portion of the determinant. It will be the minor of the element A. So the not highlighted portion, if it is written in a determinant form, the not highlighted portion is a 2 by 2 that determinant, 2 rows and 2 columns, a second order determinant. It will be the minor of A. we take another example. We take the similar determinant and we have to find the minor of the element E. Then what is the process? First highlight the row containing E and then highlight the column containing E. Now the rest portion, that is A, C, G, E, if it is written in a determinant form, then it looks like A, C, G, I. So the elements in the same row are written in the same row, or the elements in the same column are written in the same column. Then this determinant is called the minor of E. Now we'll find what is position sign of the elements in a determinant. Suppose we are taking that determinant of order 3. Now we will see what are the position signs of each element of this determinant. So we take first the element A and we give this sign plus. Then we will see we will change the sign in the next element alternatively. The next element along the row is B, so we will give it minus. The next element is C, we will give it plus. Then come to the first column. The next element of A is D, we give it minus. Then the next element is G, we give it along the row we will give plus, along the row we will give minus. Then again along the column next to D is G, so if D has the sign minus, G will have plus. Then the next along the row to G is H, then next to H is I, will give it plus. So if we take any direction along row or along column, you will see the sign changes alternatively. Just remember that the leading element A, this is called the leading element, the leading element A has the sign plus. Now we will see what is cofactor of a determinant. We will need these position signs to find the cofactor of any element of this determinant. Suppose we have to find the cofactor of the element A. Then what we will do, you will highlight the first row containing A and the first column containing A. So we will have the minor, we will get the minor of A. So what is the process of finding the cofactor of the element A? It will be the sign of A. We have noticed the sign here. A sign of A is plus here. The sign of A and the minor of A. The minor, we have learned the minor earlier. If after highlighting the rows and columns containing A, the remaining portion, the remaining determinant is the minor. So just the difference with the difference of cofactor with minor is that it has a sign. Minor didn't have a sign, but here cofactor has a sign plus, which is the sign of the element of which we are finding the cofactor. Then again take another example, the cofactor of H. We are finding the cofactor of H. Then we have to suppress the row containing H and the column containing H. So you will have the minor as A, C, D, F and the sign of H. So the sign of H is a sign of H, the cofactor of H is equal to sign of H into minor of H. The sign of H here is minus and the minor of H is A, C, D, F. Now we will see how to expand a third order determinant. We have already seen how to determine a second order determinant, that is containing two rows and columns. Here we will see how to expand a third order determinant. Now we will take a third order determinant. There are two ways to expand a third order determinant. First along the rows and the second is along the columns. Now we will first learn how to expand along the row. So we take determinant of third order. Now we take the first row. You may take any other row. There are 3 rows, so you may take any row, first row, second row, or third row. For an example, we are taking the first row, so we are expanding along the first row. So what we will take now, what is the process? The process is that the formula is that the first term a into cofactor of a plus b into cofactor of b plus c into cofactor of c. We have already learned the cofactors, how to find the cofactors of each element. Now to find the cofactor, we have to know the position signs of each element. So the first a into the cofactor of a means plus sign into the minor of a. Minor of a means if we suppress this row and this row, we will get EFHI. Then we take minus, but here was plus. Why? Because cofactor of b has the sign minus, so this sign becomes minus. Then b into the cofactor of b means minus sign into the minor of b. Minor of b means suppress the row and the column containing b, you will get DFGI. Then the c and cofactor of c. Since c has the sign position sign plus, so we will get this will be plus, and suppressing the row and the column containing c, will give DEGH. So c into DEGH. Now if we expand every this second order determinants, we will see EI minus HF minus B into DI minus GF plus C into DH minus EG. Now we will see how to expand along the column, along any column. So for an example, we are expanding along the first column. So we take the we have highlighted the first column. Now the process is similar to the process to expand along a row. A into cofactor of a, d plus d into cofactor of d plus g into cofactor of g. So to find the cofactors, we have to know the signs of the corresponding elements. So now the cofactor of a has the plus sign and the minor of a is EFHI, so a into EF into HI. The cofactor of d, it will have a minus sign, so a minus. Then that minor of d is BCHI, so BCHI. Then g has the plus sign, so plus sign. So suppressing the row and the column containing g, it will give BCEF, so g into BCEF. And then multiplying this, the expansion of the elements and the determinants, EI minus HF minus d into BI minus CH and g into BF minus CE. So this was the expansion of any determinant.